Hello again, and welcome back to the Applied Imperative podcast. In this episode, we continue discussing model-based systems engineering and how organizations can approach the adoption of such a framework. We also introduce a model we have developed to help companies assess where they land from a maturity perspective in the MBSE journey. I really hope you get a lot of value from the discussion.
It's interesting, maybe just to pivot into what challenges you see with MBSE. I know you've mentioned before, organizational, kind of change management, from the top down, like how do you get everybody around the same philosophy and methodology? Is there anything you see there that the companies would need to think about if they were considering a model-based systems engineering approach?
Well, there's all kinds of ways we could go about it, but we're talking the fact that people have been for so long used to doing a spec, then you design, then implement, then integrate kind of a practice, that now we're crossing over into an organizational problem. In other words, you've done things in certain ways, certain times. So an example, so let's say if a regulatory or a customer requirement comes down, that's going to require that we change something in the design. Today, the way it works is that, and you tell me if I'm wrong, Dale, get a CCB together, we meet in a conference room and hopefully get all the experts together in the same room at the same time, manufacturing, reliability, safety, all those people, they all come together and you say, this is the change to a requirement. Where does it go? Let's see what the impact is. And you produce a charge number, then everybody goes to work out finding where it goes, comes back 3-4 weeks later, whatever it is. And they say, okay, this is where we think it goes. And everybody says, well, do we need to do this? And you gather up all the things and you have this huge thing called a change package, right? And then you say, okay, go execute that. And then you have this interesting, what's the word I'm looking for here, Race? You have multiple releases that take place over time and you put them in a block and you say, we're going to put it out. This release is going to be in that block. It's just an incredibly complex practice. In fact, there's whole certifications that go with that, right, Dale? That is just not sustainable and as a general rule as we go along here. So the question you're asking is, so how do we do this? That's an organization change. Imagine a different approach. Are you familiar with the INCOSE vision on this one, Dale? Did we share that with you in the past? Sure. Let me share it with you guys. Compare that with this thing right here I'm about to show you. This is what they call the INCOSE vision. Systems engineering was accused of being too aerocentric, so we went with a car, okay? When we first started down this path, we realized that we need to have this model-based practice to transform systems engineering from documents to a model-based practice. And we ran into organizational issues even within inside of INCOSE, okay? But the idea was we needed a story to describe what would this look like when we achieve this integrated model-based systems engineering capability. And so we said, okay, this is how it will look in the future someday when we get all these things talking to each other and when a change takes place, so forth and so on. So I walk up to my car. Let's say, for example, I have a regulatory change that takes place. Here, for whatever reason, they say we've got to change our emergency braking distance from 110 feet to 90 feet. That's a new regulatory change. And so, like I said, in your world, you would have started this CCB, gathered all the experts together, and you'd go off for weeks, months. I've been associated with changes that have taken years to deal with, as you probably have as well.
Yeah.
Anyway,
Me too.
And so in this case, because we got this integrated capability with many different models contributing to this, we should be able to tell in near real time these areas of the vehicle are potentially impacted as a result of this change. And then you could drill into it, for example. Here, for example, we've drilled into the braking system. And here I see 7 different models in reporting their perspective on the problem. Here you see at the 12 o'clock that I've got the hydraulic fluid that's not compliant with the regular. Okay, that's an easy one. But we probably expected thermal issues. You see that at 3 o'clock. As I come around here, I see I'm okay on ergonomics and hydraulic pressure, but for whatever reason, we've thrown a fault in our cruise control. I'm not sure where that came from. And our mean time between failure calculators tell us we got an issue at 3,000 hours. And for whatever reason, we've gone to 18 amps or electrical circuit. So we drill into that. We find we've blown a fuse. We follow that to the schematic and from there to the harness. And here for the first time, we realize that problem we never knew we had before because it's never happened to us before. Here, when that sensor failed short at 3,000 hours, hopefully it's in their driveway, not on the freeway. Then we realized that we got a problem that caused this cascading effect, which led to the blown fuse. Okay, now I know that. Now I got a new failure mode to keep up with, right? And while I'm here, I might as well go chase to the math model that produced that cruise control code and see why it is I'm having that problem. And while I'm here, I might as well go look at the actuarial tables because I should be able to get a better insurance rate, right? So that what you just saw there was following that problem at the speed of thought. Okay. I'm chasing it, and there's no one tool that would have caught this thing. No one domain would have caught this thing. It's a combination. And so the idea here is that it's at the combinations with the surfaces, and this is the value you get from this integrated MBSE capability. That's what we're after, trying to get to people, because this is the only way, per the Aerospace Vehicle Systems Institute, we can survive. Okay, this experience. We have to start integrated, we got to stay integrated, and of course, that's the interesting thing about systems engineering, is even making no decision is a decision, right, Dale? Everybody's moving on with or without you. And so the idea here, you guys have all been experienced. I've been in this experience where somebody says 6 months later, we have this problem. It's more serious than I thought. We're going to have to redesign. And you say, well, I wish I knew this 6 months ago, right? Right. But now we're making interesting choices. Like I think you were talking earlier about the column of shame, Dale.
Famous column of shame. Yeah, right.
This is what makes it interesting. Now, there is some value in these artifacts that are left behind. Like, for example, the Leaning Tower of Pisa is a failed architecture, but it's a great tourist attraction, right? Now, you don't want to ever go to the Italians and say, hey, that's a failed architecture. And I remember at the time they were starting to deal with the fact that it was leaning more. And I said, well, I'd suggested to one of my Italian friends, while you're straightening it up, might as well go ahead and straighten it up right, get it right, And they said, no, we can't do that. But there's value there. But anyway, yeah, that's right. The upright, nobody come find the upright Tower of Pisa is probably what it was. But anyway, yes, what you're looking at here is the column of shame. In my engineering school, freshman, after the test, got accepted. On orientation day, they walked you down in the basement and they showed you the column of shame and made you touch it. Because this is what happens if you don't get it right to begin with. That's the object lesson that we're after trying to get across. So
that is a really great lesson, very very tactile, practical one as well. So I love that, and I love the automotive example you gave as well. When I think about software-defined vehicles, everything's moving again to be even more integrated in vehicles now. Lots and lots of software, and lots of cabling and communication between systems, and having the ability, again, with a model-based systems engineering approach, to tie everything together, to trace the impact of a regulation change or a requirement change to all of the discrete subsystems, all the way down to the wiring level. And if you change a parameter higher up, this regulation has changed, etc. Visualizing that spider webbing, cascading effect throughout the design and all of the parts. And that is absolutely possible today with an MBSE approach and with modules like the change management module inside the Team Center, for example. And you can very rapidly gather all of the inputs. These are the parts, assemblies, drawings that are impacted. Here's the cost impact. Here's the amount of design time that it will take. So having that system where you can rapidly iterate and then, by extension, become much more competitive in the marketplace, I think is really, really powerful. So thanks for taking us through that, Mark. That was great.
You're welcome.
I think the last thing I'd like to touch on before we wrap up is, some of the problems that we've discussed and trying to piece together organizationally, where am I at, for example? How do I actually move in a direction of how I can improve my maturity? And you've developed a really fantastic, very visual tool where people can kind of snap the line to see where they are today. And from that, look at what tangible tactical steps they can take to increase their maturity and move in a more kind of MBSE positive direction. That tool is available at appliedcax.com, and it's called our MBSE Maturity Assessment Tool. So you just want to give a very quick summary of that, Mark, and the idea behind it?
Okay, so what you're looking at is this first column is a description of all the things that systems engineers are supposed to be doing. This is per the ISO standards, like, for example, they define requirements. Hopefully my mouse is coming through to highlight these things. I define what the requirements are and so forth and so on. And interfaces, I define what an interface is, and I define who's supposed to be responsible for it. I do all those kinds of things. I could be doing this job of systems engineering in an interesting way. We talked about this problem that system engineering has generally of if you're not doing it fast enough, etc., you've got to be cross-domain. So the idea here is that we've documented the stuff that system engineers are supposed to be doing. We ask customers what technologies they're currently using to do this job the systems engineers are supposed to be doing. Like, for example, where do you manage requirements at? Do you manage them in uncontrolled spreadsheets and documents? Do you manage it in SharePoint? Do you manage it in some kind of standalone requirement environment? And as we move to the right, we're moving from this disconnected world to our connected world. Remember, what we're after is trying to get the implication of a change to everyone that's impacted by it now versus later. That's the important aspect of this. As I move to left to right here, I'm getting more and more integrated. The best of all worlds is an individual requirement is showing up as part of the product baseline. I'm talking about the product structure of the entire aircraft also has got requirements to go with it. So when I set my, say, version B of my aircraft, I'm picking up version B of all the requirements that applied to go along with it. And when that happens, that means I can relate a requirement to a task in a program schedule, to a part, to a manufacturing process, to a test case, all those kinds of things. And if I can pull that off, that means that when that requirement changes, I can get an instant impact understanding of all the things that are going to be impacted as a result of this change of this requirement. These test cases are going to have to be redone. This manufacturing process is going to have to be checked out. Give you one more example. Interface management, for example, is another important aspect. This is where we manage our interfaces, and it turns out that all the bad things in a product's life happen at interfaces, right, Dale?
Yeah, true. Yeah.
Right? So the idea here is that we could be managing those interfaces in documents. I could be managing them individually, but as I move to left to right, we have tools available today that will actually allow you to take a function, allocate a function to something, and then when I allocate that function to something, that bursts an interface that then flows through the entire product development practice. That's what Teamcenter can do for you now, for example. And the idea then is that when an interface changes, you get implications of all the places it goes. Okay, imagine walking up to a wire or to a pipe in a hydraulic line and asking what function are you performing? Are you carrying? That's an important knowing now is really pretty important. Anyway, what we did with that kind of matrix, we go and we ask the question of people: where do you manage your requirements? Where do you manage change? Where do you manage your parameters and targets? Where do you manage your interfaces? So forth and so on. And we've done enough of these that what you see here is the average organization here is managing their CAD data. They're managing their test case in PLM. They're managing their test cases somewhere other than that. Their behavioral models. There's some thousands and thousands of these kind of math models and otherwise that are managed outside the product. You get the idea here, and you can see that everybody. What's the word I'm looking for here? Sucks. Is that a good way to work, Dale? Challenge.
Let's go with
challenge. Okay. They're challenged. By the way, this is an example. We've done hundreds of these. Here's the best we've ever seen in Aero. This is an optimistic model. We ask people, think about the best experience you've ever had in your entire life in a program. And this is the best they came up with. And so this is an optimistic model. And so you can kind of think to yourself, well, if this is the best, imagine what the worst might be like. But anyway, and then of course, here's the best we've seen in auto. And here we can predict with 95.6% confidence that you are here.
Yeah. Yeah.
And now the question you might be asking yourself was, if I'm here, what do I do about it, right? And so what we do, by the way, this is our universities aren't helping us in this situation. That's another story we can talk about. But the idea here is that we know which tools you're currently using to do this job. And we know why you're asking for these integrations between reliability and requirement tools, for example. And as we look at this, this means that we need to integrate this with the entire product lifecycle so we can now have the relationships underneath this thing so we can see where we want to go. And from this, we can say, we think that the right answer is to start where you are with managing requirements and start moving out from there, get those requirements into the product lifecycle and start moving through the practice of getting the value out of what you've already got confidence in. Most people have confidence that they're managing requirements, but the problem there, Dale, I guess I'll wrap up on that is we're just not managing requirements to manage requirements. We want to manage them so we know where they go, right? That's what we want to do. That's right. And so the idea here is if I pick a problem, if I want to do the organization change that we're talking about here, we take these requirements, we integrate them with the product lifecycle so we get the value of understanding where they go. And now we've got some value here that we can point to for everybody in the entire world to say, see, and then everybody wants to be like you. And the next thing you would do is probably go to test, get test tied to requirements and so forth. And this is how you do the organization change that we were talking about earlier to take advantage of this.
Yeah. Yeah.
Okay. So
that's great.
This is going to be available online here shortly, right, Dale? So
Yeah, it is. Yeah. So if you go to appliedcax.com and it's a slightly different user interface. It's really clean, really easy to navigate. There are little sliders, I think, and we'll flash that up and we'll put that into the show notes as well so people know where to go. I think it's a really useful tool to visualize what can be a bit of a daunting or a complex topic to some people, and it gives you a really clear indication, as you've explained, where you are today and how you can move your organization, meaningfully into a more mature direction. So that's really great, and thanks for helping us put that together.
you're welcome.
So, Mark, it's been a great discussion. Let me just quickly summarize some key takeaways for people that are listening or watching. I think, MBSE has had a history of, growing in complexity and the potential of it to help people that are designing very complex products. It does and can help avoid very costly last-minute integration problems. You mentioned integration again just a moment ago there. Integration is where the magic happens or where things fall apart. And so having MBSE and an MBSE type approach helps us avoid that cost of late discovery oftentimes, if it's done correctly, of course. Organizational change is a key element in terms of how companies need to think about that. It's not just, well, here's MBSE, go ahead, deploy it, have fun. You need to think about all of your processes and tools and how everything is stitched together, how your teams are arranged, how you drive change, et cetera, et cetera. This isn't going away. We've seen how product complexity is just continuing to increase to the point where for certain products like aerospace products, it's almost untenable right now. And so we have to have a paradigm shift where we're using new tools like MBSE as part of the tool set to bend that cost curve back in the direction it needs to go. I think, with the evolution of SysML v1 into v2 now, it's a kind of watershed moment where hopefully we'll see an increased adoption because v2 should be much easier to learn, the syntax and the grammar and all that kind of stuff that you mentioned. And I think as well, just capturing what we just discussed here, we have a great tool that people can go to on our website, appliedcax.com, look at that MBSE maturity assessment tool, see where you're at today, see what you can do to meaningfully move yourselves in the right direction. And I think that about wraps it up. Any final thoughts, Mark, or did I cover everything?
I think you did really well covering it. I'd just like to add one final thought here. I oftentimes run into lots of people who say, well, what's the benefit of doing systems engineering, period, or model-based systems engineering? Is it worth it? I remember I was back at TI and I reached in my career path the maturity where I was managing a program, and I asked the old timers, how much time do I put in my program schedule to integrate my chipsets, my chips? And the old timers said about 50% of your program schedule will be spent over there on integrating these chipsets. I thought, well, I said, where did that come from? I want some references. And they said, I don't know, but it works. And I was so surprised by that. But over time, what's happened is I've asked that same question. How much time did you put in your program schedule? And I could ask Dale this same question. How much time do you put in your program schedule to deal with integration problems? And Dale will tell me without batting an eye, probably about half of my program schedule will be spent dealing with that problem. It's everywhere. It's not just aero, it's auto, it's all kinds of places. And then the question I'd ask everybody is, well, why would you put up with that? Why would you spend half your program schedules trying to get everything working together? And I always get the blank look. I didn't know there was any choices. And what we're proposing is by doing this kind of implementation in an integrated way as part of your product lifecycle, we hope that we're going to catch these problems as they surface rather than wait to integration time to try to figure out what to do about the problem.
Yeah, that's it. I think one last point that I'd make just hanging off of that, when you're capturing it late in the product development cycle, as we all know, it's the most expensive time. You've spooled up your team of production folks that are actually making the product ready to sell it as soon as it's certified, for example. You've got a whole test team, maybe. You've got a very expensive asset in the form of an aircraft in particular, if that's what you're working on, sat there that isn't flying, for example. And so those problems manifesting themselves at that phase of the program can be extremely costly, as we've seen, unfortunately, on some recent programs. And again, we have to bring every tool to the battle to try and, again, bend that curve and stop that late discovery and get the cost down. So, Mark, thanks so much for joining us. Really appreciate the discussion. I think some great insights there for people to take away. And we'll see you next time.
Thank you, guys. We'll see you.